Hello everyone, I am Ayush Agrawal from ABES Engineering College, and in our today's lecture we'll discuss some additional relational algebra operators. Before starting our today's lecture, let us discuss what we have discussed in our previous lecture. So in our previous lecture, we'll discuss some fundamental operators of relational algebra. Like we have discussed select operator, project operator, rename operator, and different set operators like we have union, intersection, and set difference. Now in today's lecture, we'll discuss some more relational operators like we have Cartesian product and joints. So in this case, so first of all, we'll discuss the Cartesian product in relational algebra, and we'll discuss with the help of an example again. So if we talk about relational algebra, we have a Cartesian product and it will be, it can also be used to combine the tuples from two relation. And it is also known as cross product, right? So if we'll talk about Cartesian product in DBMS, it is an operation used to combine tuples from two relation in a combinatorial fashion. So basically, till now we have used select operation, project operation, and rename operation. So in that we have understand that only single relation can be used. And when we have discussed the set operator, we have discussed that we'll use two different relation, and onto these relations we have to apply set operators. Now in Cartesian product, again we can have multiple relations into it, and onto that relation we can apply Cartesian product, right? It is also called as cross product or cross join, and it is denoted by this cross operator. So here we have relation R, under that we have some number of attributes, and we have different relation S, and we have different set of attributes into it. Now if you talk about Cartesian product, if a relation R1 has n number of tuples and a relation R2 has m number of tuples, then the resultant relation of R1 Cartesian product R2 will be n cross m number of tuples. And if we talk about the number of columns we have in Cartesian product of two relation, so if R1 has m number of attributes and R2 has n number of attributes, then the resultant relation will have m plus n number of attributes in that order. Now, unlike the set operator, Cartesian product does not need to be a type compatible. So basically, if R1 has three attributes and R2 has two attributes, then also we can apply Cartesian product into it. Let us understand with the help of an example here. So basically, we have two table here. Under that, we have first table. In first table, we have two attributes A and B, and in the second table, we have three attributes like C, D, and E. And here we have two tuples, and here we have basically four attributes, right? Four columns, four tuples. Now, when we'll apply this cross product or Cartesian product into it, so you can see that we have also discussed that if R1 has m number of tuples and R2 has n number of tuples, then the resultant relation has m into m n number of tuples. So here we have two number of tuples, here we have four number of tuples. So in the resultant relation, we have total 8 number of tuples. And if we talk about the number of columns we have in Cartesian product, so here we have two attributes, here we have three attributes, so here we have total m plus n, it means 5 number of attributes in this particular order, right? Now how this Cartesian product will work? Now the first tuple of the relation R1 will make a combination with all the tuples of another relation R2. So you can see that this alpha and 1 will make a combination with alpha 10 and A. So you can see that alpha 1 will make a combination with alpha 10 and A. So again alpha 1 will make a combination with A, B, and small a. So that will be a second tuple of relation R2. And the tuple of relation R1 will make all the combination with all the tuples of the second relation. Now this is the case for this particular first tuple, and again the second tuple of relation R1 will also make a combination with all the tuples of the relation R2. So we can get here 8 number of tuples into it and total 5 number of attributes into it. Now next we have joins. This is a very important topic when we will talk about relational algebra, or when we'll talk about a structured query language, because very frequently we'll have multiple tables in our database, and the use of joins is basically to retrieve the information from multiple tables. Basically, majorly we'll get that situation where we want to retrieve the information from different tuples, so from different tables. So in that case, we'll use this join operator. Now the sequence of Cartesian product, what we have already discussed, followed by select operator, is used quite commonly to identify and select related tuples from two relation, that is called as joins, and that combines the sequence into a single operation. So basically, if we want to apply join, so you can also say that first of all we need to apply Cartesian product onto two different relation, and then followed by select operator to display the result of the relation. So now the general form of a join operation on two relation is this. We have R relation, and under that we have n number of tuples. We have S relation, and we have an m number of tuples into it. Now the when we want to apply the join operator, so this will be a operator used for the join, and here we have applied onto two relation R and S, and this is the join condition, right? So we can also apply the join condition onto this particular scenario, where R and S can be in any relation that results from general relational algebra expression. And again, in case of join, we do not need to be a type, we do not need our relations to be type compatible, like Cartesian product. Now we have some properties of joins. So first of all, consider the following join operation. Here we have R1 relation, and here we have S relation, and this is the join operation. So basically, while applying the join operation or operator, some column must be same. At least one column will be same in both the relation. Then only you can apply the join operator into it, right? So we have seen here that R dot AI equals to S dot BJ. So basically we'll have at least one attribute in both the relation that will be common. Then only you can apply join operation on those particular relations. And the result is a relation Q with a degree n plus m attributes, because we are using Cartesian product, and we have already discussed that while using Cartesian product, if a relation R has n number of attributes and S has m number of attributes, then the resultant will have n plus m number of attributes, right? Now the resulting relation state has one tuple for each combination of tuples R from R and S from S relation, but only if they satisfy the condition this. We have discussed in this case scenario that while applying the join operation onto these particular different relation, at least one column in both the relation must be same. Then only you can apply join operator. Okay. Now, if R has n R number of tuples and S has n S number of tuples, then the join result will generally have less than n R into n S number of tuples. What does it mean? We have seen that in the case of Cartesian product, if relation R has m number of tuples and relation S has m number of tuples, so the resultant relation will have n into m number of tuples. But in case of join, if R has n number of tuples and S has m number of tuples, so we'll get the resultant relation will get less than or equal to n into m number of tuples. Why? So that because in case of the join operator, only the related or matched tuples will appear in the result. If the particular relation if the particular tuple does not have a matched tuple in the other relation, that it will not be included in the resultant relation, right? Now we have different type of joins in database management system. First of all, we have inner joins. Under inner joins, we have theta, natural, and equijoin. And other we have outer join, and under outer join we have left, right, and full outer join. We'll discuss one by one with the help of an example. So let us discuss first of all inner join. So inner join is used to return rows from both the tables which satisfy a given condition, and it is the most widely used join operation that can be considered as default join type. So basically, while using inner joins, first of all, uh, this is used to return rows or return tuples from the two or more tables which satisfy the given condition. And while applying the inner join, this must be considered that it is a default join type. It means that if you will use a relation if we will use join operator between different relations, so by default inner join will be applied. And in this scenario, in this inner join, we have different type of inner join. First of all, we have theta join, then equijoin, and then natural join. So let us discuss first of all what is theta join. So basically, it does allow you to merge two tables based on the condition represented by a theta. So you can see here in this case, right. So in this case, we have two relation, and in two relation, we are using join, and this is a theta join. And here we can apply a particular condition that must be satisfied while applying join into it. So in case of theta join, it is the select, it is a result of performing a select operation on the product, as we have already discussed. Theta joins works on all comparison operator, right? So this will be important, that theta join works on all comparison operator, that must be greater than, less than, greater than, equal to, less than, equal to, not equal to. These all are the comparison operator, and it is denoted by theta. What is the general form? We have already discussed that the general form of a theta join operation on two relation is this. We are using R and S. These are the two relation onto which we will apply theta join and with a join condition. Algebraic rules say that R1 and R2 have a theta join with this join operator, and it is similar to the R1 cross product R2. And what will be the result of this resultant? After that, we'll apply select operator with theta or with some join with condition. Let us take an example here. So here we have two tables. First of all, we have age group, and next we have customer table, right? So what we need to retrieve, display the name of the customer along with the age group in which his or her age lies. So this is the case. We want to retrieve the customer name or customer name or customer information along with the age group in which his or her lies. So if you see in this particular table, we have minimum age, we have maximum age, and we have age group. And in this customer table, we have customer name and age. So first of all, we need to apply the cross product onto this both particular table. So you can see here we have applied the cross product customer and age group, and after that we have used select operator, right? And under select operator we have used here the theta condition or theta join condition. What will be that condition? Age should be greater than equal to minimum age, and age should be less than equal to maximum age. So this will represents the theta join, right? We have used here theta join, and the resultant of this relation after that will return only the customer name and age group. So in our previous slide, we have seen that in this scenario that we will apply some Cartesian product on to the relation R1 and R2, and after that we'll apply select operator with this theta join, and theta join represents the condition onto the Cartesian product of the two different relations. So this will be the output we'll get after applying this query onto these two different relations. We'll get customer name and we'll have this age group. So if we talk about this Rahul, so Rahul age is 35, and we'll check here the age group. So this will be the age group for the Rahul. So the age group will be 31 to 60. If we talk about this second tuple, her age is 23. So it will lies in between 18 and 30. So it will lies in between, the age group will be 18 and 30, and so on, right? Now next we have equijoin. So basically, equijoin is commonly used to join two different relation with the equality comparison only, or equality condition. Equijoin is done when a theta join uses only equivalence condition. So in a previous example, when we have discussed this theta join, here is a some condition, and is this condition we have discussed that theta join works for all comparison operator, that is greater than, less than, greater than equals to, less than equals to, and so on. But if this join condition represents only equals to operator, or equals to comparison operator, then this theta join is considered as equijoin. That is means that equijoin is done when a theta join uses only the equivalence condition, right? Now, such a join where the only join comparison operator used is equals to is called as equijoin. And in the result of equijoin, we always have one or more pair of attributes that have identical values in every tuple, right? Then the result relational syntax is this. We are using two different relation and we are applying this join condition into it, and the condition here is r dot a equals to s dot a. It means while applying the equijoin, we need at least one column to be same in both the relation. Let us understand with the help of an example here. So there we have two tables named as student and student registration, or subject registration. Here we have different columns named as registration number, name, age, and phone number. Here we have subject registration and subject. Okay. Now show the details of a student and the subject registered by him. So what we have to identify, we need to identify the student name and the subject registered by him. So here, first of all, we'll have to apply the cross product onto these two particular tables named as student and student registration, right? After applying this cross product, we have apply sigma or select operator with this equal operator condition. What is this equal operator condition? That registration number equals to this S registration number, right? So basically, in these both the relation, we have one at least column, that is registration number, that must be same. Okay. Now only the matched tuples will be considered in the resultant relation, and you can see that because we have not applied the pi operation here, so all the columns of both the relation will be considered into this resultant relation. And you can see that here we have four number of columns. So here we have four number of columns. Here we have two number of columns. Here we have two number of columns. So here we have four number of columns, and here we have two number of columns. So in our resultant relation, we have six number of columns. And if we talk about the number of rows or number of tuples, so here we have two number of tuples. Here we have three number of tuples, but here we have only three number of tuples. While in Cartesian product, if this will be the scenario, so there will be total six number of tuples. But we have already discussed that in case of join, we may get less number of tuples as compared to cross product, right? So basically, if we talk about this BIT001, we'll check here whether it will have a match tuple or not. So here BIT001 will have a match tuple. So this will be the first tuple that we will get, BIT001, and Ram next 15 and his phone number with this S registration number that will be common, and his subject is physics, right? Now you can see that in the registration number and S registration number in the resultant relation will be same. So you can see that BIT 023, here BIT 03023, and here also BIT 023, and here also BIT 032, 0323. So in the case of equijoin, first of all, in the theta, we'll use only equal to operator, and while applying equijoin onto two different relation, at least one attribute must be same. Now next we have natural join. So another variation of join, it is also called as natural join, denoted by this star operator, was created to get rid of the second or superfluous attribute in an equijoin condition. What does it mean? You can see here, while applying equijoin condition, here we have four number of attributes, here we have two number of attributes, and in both the relation we have one attribute that will be common. But in case of equijoin, we have both this relation, both this attribute in our resultant relation. But when we'll talk about natural join, this superfluous attribute will be eliminated. If we have a common number of attribute in a particular resultant relation, only one column will be represented. Okay. Now, the standard definition of natural join requires that the two join or attributes or each pair of corresponding join attributes have the same name in both the relation, right? So it must be same name in both the relation. We can also perform a natural join if there is at least one common attribute that exists between two relations. We have already discussed that. A natural join is a shorthand equijoin where the equality applied to all the shared attributes, right? So in this case, you can see that we have applied join condition on two different relation R and S, and here we are applying the intersection on the attributes of R and attributes of S. Okay. Now, let us understand with the help of an example here. We have two tables under this example. We have course and we have HOD. Now, what we'll get when we'll apply the natural join, we have seen that this star operator is represented by natural join. So, when we'll apply courses, natural join and HOD, so what it will return first of all only four columns. Why? Because here in course ID and HOD, a common attribute is department. So department will be considered once only in our resultant relation, right? And other attributes will be considered as same, like CID, course and department. So you can see here department is the common attribute in both the relation. So department will be considered only once, unlike your equijoin, right? And then CID, then course, and then head. And the scenario and the processing of this particular operator as natural join will be same as we have discussed in equijoin. The difference is basically the second or superfluous attribute will be eliminated in case of natural join. Now next we have outer join. We have discussed that join are classified into two types, inner join and outer join. In case of inner join, only matched tuples from both the relations are considered in the resultant operator. But in the outer join, we can have also the unmatched tuples of relation. How and when, in which case, we'll discuss now. Now, the outer join operation is an extension of join operation to deal with missing values, right? First of all, it is used to deal with the missing values. Let us consider two table here. Here we have employee table and here we have FT works table. Now, the objective, what will be the objective? Generate a single relation with all the information, that is employee name, street, city, branch name, and salary about full-time employees. Right now, what will be the possible approach? The possible approach is natural join. So when we'll apply natural join, so first of all, we'll see whether we have a common attribute into those relation. Yes, that will be employee name. So you can see here employee name is considered only once, and then street, then city, then branch name, and then salary, right? Now, if we see this resultant relation, we have lost the street and city information about Smith. You can see here this Coyote have a matched tuple here, so it will be considered in the resultant relation. If we talk about this rabbit, so rabbit also have a matched tuple in the full-time work employees table, so it will be considered here also. If we talk about Smith, so Smith does not have a matched tuple here, but Smith has street and city, right? So this information have lost, or this information is not retrieved when we'll apply the natural join operation. So in this case, we'll use the outer join operation. Okay. Now to avoid the loss of information, we'll use outer join, and it will be considered, or it will be classified into two types, that will be left outer join and right outer join. And if we combine both the left outer join and right outer join, then we'll get the full outer join. We'll discuss one by one with the help of an example. So left outer join, the syntax or the operator will be used like this. In the right outer join, we'll have this symbol, and full outer join will have this symbol. Okay. Now we'll discuss one by one. First of all, we have left outer join. So left outer join takes all the tuples in the left relation that did not match with any tuple in the right relation, pads the tuple with null values for all the other attributes from the right relation, and then adds them to the result of natural join. What does it mean? It means that, first of all, left outer join, when we'll apply the left outer join onto two different relation, so you can consider that first of all we'll apply natural join onto it, right? After that, we'll check the left relation, because we have used here a left outer join. So we'll check the left relation if if any particular row is missing or not. If yes, so we'll also included the result of that particular missing tuple into the result of relation. And because that tuple does not have the match tuple in other relations, so in that case we'll use null values here. Like in this case, we have two tables, employee and full-time works table, and we have applied left outer join. So first of all, as we know that, first of all we will apply natural join into it. So we'll use natural join, and we'll get this coyote, because this coyote has a match tuple here. Rabbit also will have a match tuple here, and Williams will also have a match tuple here. But when we'll see this left relation, this tuple, Smith tuple, will does not have a relation or match tuple into the right relation. So in case of left outer join, we'll also add this particular information in our resultant relation. So you can see that here we have used Smith, is his street, his city, because his branch name and salary is not given into full-time works. So here we have applied null. So in that case, we'll apply the left outer join. First of all, we will match the tuples between the two different relations, and then we'll check whether any tuple is left in the left outer join. Then that tuple will also be included in the resultant relation. Same with the case of right outer join. Now in this case, we'll first of all apply the natural join, and after that we'll see the right relation if any tuple is left out or it does not have a match tuple from the left relation. So if we talk about this in this situation, so we'll check this case. Coyote, we have a match tuple here, so we'll included this coyote. Rabbit, we have a match tuple here, so we have used here rabbit. Williams, we have a Williams match tuple, so we have included here. Now we have Gates. This Gates does not have a relation with the employee information, right? So in this case, Gates is a tuple that does not have any match tuple from the left relation. So in case of right outer join, we include this gate information also into our resultant relation. So now gate information, employee information we know, so we have used gates here. Is street and city is not known, because this information is not matched with the employee table. So here we will apply null, and after that his branch name and city has been known, so we'll use that particular information into our resultant relation, right? So this will be the case of right outer join. Now next we have full outer join. As we have mentioned that in our previous case, in this case, so basically when we'll combine the left outer join and right outer join, we'll get the full outer join. What does it mean? It means that whenever we'll apply full outer join, first of all we'll use natural join to identify the match tuples, and then we'll identify both the relation in both the relation those tuples that does not have any match tuple that also be included into the resultant relation. So you can see that in this relation that coyote, rabbit, and Williams, these have a match tuples from FT works table. So these tuples can be included into a resultant relation. Now this is a full outer join. It means we will have to included the unmatched tuples of both the table. Right. So in case of employee, this Smith does not have a match tuple from FT works table. So it will be included, and will know we does not know the information of branch name and salary, so it will be considered as null. And if we talk about the right relation, Gates does not have a match tuple from the employee relation, so it will also be included in the resultant relation, because we does not know the street and city of the Gates, as it does not have any match tuple, so it will be considered as null. And branch name and salary we know, so we have mentioned here. So in this case, join operation will work. We have discussed here, first of all, the Cartesian product, and then we have discussed the concept of join. Join, we have different types: inner join and outer join. Under inner join we have theta join, eq join, and natural join. And another case is for outer join. So we have left outer join, right outer join, and full outer join. Now, these are the references from which the content is being taken to execute this video. Thank you so much.